Hey guys, in this video I want to show you how to render your particle simulation with some custom object on the point with Redshift Proxies. So let's dive in. So I've created a new blank scene and the first step is to create a particle simulation. So to do that, let's add a new geometry container. Here you can dive inside and we can add a first geometry. So we can start by adding a sphere. Here you can press P to open the parameter of the node. And here you can change from polygon mesh to polygons and you can increase the frequency to 30. Here you can add a normal node and here you can add a point warp. So we can add a bit of noise on the spheres. So here we can dive inside the point warp. We can add a turbulent noise. Here you can plug the positions on the position input and you can plug that to the color attributes. So here you can animate this noise over time. So to do that, you can add a multiply constant. And here you can plug the time value in the multiply constant and you can plug the output on the offset of the noise. So here you can put the value of the multiply constant at 2, but you can change this value if you want to animate the noise faster or slower. Here for the turbulent noise, we want to have access to the parameter in sublevel here with the point warp. So to do that, we can right click on the node and you can click on Vex Warps options and we can click on create input parameters. So now we can go back on sublevel by clicking on Geo 1. So now you can see that we have access to all the noise parameter here. And in my case, I will change the noise type to 0 centered. I will increase the frequency to something like 2, just a bit more. I will increase the amplitude to 10 and I will decrease the roughness to 0.4. So now I can add a blast node. And here with the blast node, I can type at cd.air is below 0.5. And here you can put that to points. And now you can see that we can keep only the white part of the spheres. So now we can add a clean node and we can add an attribute delete and we can delete the color attribute because we don't need it anymore. So now you can see that we have animated a noise over time like this, but maybe we can remove the little tiny pieces of the sphere. So for example, this one, also this one, and so on. So to do that, we have a node called labs delete small parts. And here with this node, we can put a threshold and I think we can put the value at 0.01. So now in that case, we can keep only the big pieces. So now let's add an edge smooth node. And here with the edge smooth node, we can select these options, include unsure edges. And now you can see that we have something way more smooth. Now we can see the result of the animated noise. So now we can use this moving geometry as a source for the pop simulations. So to do that, we can add a scatter node. And here with the scatter node, we can increase the point number. So by default, the point number is at 1000. We can put that to maybe something like 150,000. And here you can add a point velocity. And here with the point velocity, you can go to the curl noise tab. And here you can enable curl noise. And you can keep everything by default, but of course you can play with the value if you want. So now let's add a pop network. So here for the pop simulation, it's quite basic simulation. So we can dive inside. And here you can select the source. For the emission type, you can select all points. And here you can go into the attribute tab. And here for the velocity value, you can put the value at 0.025. So now we can add a pop wind. You can plug the pop wind on the second input of the pop solver. And here for the pop wind, we can change some settings. So we can increase the amplitude to 1. And here you can keep everything by default. But again, one more time, you can play with the value if you want. So now let's add the pop drag. And here you can plug the pop drag here. And if you want, you can play with the setting of the pop drag. But in my case, I will keep the air resistance to 1. So it's pretty much it for the pop simulation. So this is very, very basic simulations. So now we can put that in cache. So let's add a DOP import. So here in the DOP import, we can drag and drop the DOP.net inside the DOP network field. So we can do that here. And for the object, we can select the pop object and we can remove the little star here. So now we have the particles imported here in SOPs and you can put that in cache. So let's add a file cache node. And in my case, I will put that to explicit and I will put that in a cache folder and $OS folder. And for the length of the cache, I think I will put that in cache for, let's say, 100 frames. But of course, you can put that for a bit more if you want. But for the tutorial, I will keep that to 100. So here I will rename the name of the node something like particles tutorials. And here I will click on save to disk. So this is the particle simulations. So now we can delete some attributes. So we can add an attribute delete node. And you can delete everything except velocity and ID. So you can select the velocity attribute here. And you can also select the ID attribute. And now you can click on delete non-selected. So now you can add a null to specify this is the output of the particles. So we can rename it out particles.
Imagine having access to over 40 hours of exclusive Houdini tutorials, and that library keeps growing every month with brand new content. On Arda Labs, you'll find in-depth Houdini tutorials covering motion design, simulations, product visualization, and more. Plus, you get access to all project files so you can follow along step by step. And right now, we're offering an extra 20% off the annual membership, on top of the 10% discount already included when compared to the monthly plan. This exclusive deal is available for the first 30 people, so don't miss out. Click the link below, your 20% discount is applied automatically. Secure your spot before it's gone.
So now we can create some object to put on the points of the particle simulations. So to do that, we can create some like little rock stuff. So to do that, we can add a box. Here you can keep the box settings by default. Everything is at 1. Now you can add an ISO offset to create a volume based on this box. So let's select the ISO offset node, and you can increase the resolution to 50. So here let's add a scatter node. By default, the scatter got 1000 points. I think we can keep that by default. So now let's add a Voronoi fracture. We can plug the geometry on the first input, and you can plug the point on the second input of the Voronoi fracture. So now you can see that we have this result. Now let's add an assemble node. And here with the assemble, you can select the options create packed primitive. So now at the moment, as we have 1000 points on the scatter node, we have 1000 chunks for the pieces here. So we can see that we have 1000 points because we have packed primitives. So now we can add a delete node to keep only a small amount of chunks. So to do that, you can select the delete node. You can go to delete non-selected and you can select points. And here under the bounding volume, you can enable bounding box and you can reduce the size of the box to keep only small amount of them. So maybe we can keep something like 5 or 6 pieces. So yeah, in my case, I will put the size of the box to 0.2. In that case, I have 5 pieces. If you want, you can make it a bit bigger to have more randomness to the pieces, but in my case, 5 is good for the tutorials. So now let's add an unpack node. And now let's add a loop called for each connected pieces. So you can plug that here. So now the first thing is to put all of these pieces at the center of the scene. So to do that, let's add a match size node. So we can go at the end of the loop. And here, if you want, you can enable single pass. In that case, we can deal with only one pieces to see the result of the loop. So now let's add a subdivide node. And here with the subdivide, you can put the operation to open subdiv bilinear. And you can put that to 3. In that case, we have this result for the subdivide. Now let's add a transform node. Here for the transform node, I will keep everything by default except for the scale on the y-axis. I will put it to 0.4. So now I have this. Now let's convert this geometry to VDB. So let's add a VDB from polygons. Here I will decrease the voxel size to 0.0025. In that case, I have a bit more resolution for these species. And here I don't want to convert that to surface VDB, but density VDB. So now we can add a bit of noise on this VDB. So let's add the volume noise fog. It will add a bit of noise on the density. So here for the settings of the noise, you can change the amplitude to 10. Here you can change the range value to 0 center rate. And here you can keep the noise type to simplex, but it's up to you if you want to change it. And you can change the element size to 0.05. And later we can change the offset for each individual pieces. So now let's add a convert VDB node. Now we can convert from fog to SDF. So we can select convert to VDB, and here we can change from fog to SDF. And now let's add a convert VDB node one more time. In that case, we can convert from SDF to polygons, so we can convert to polygons. So now we can add one more time the labs delete small part, in case we have some little part flying around the big chunks. So here with this node, we can select the option called extract largest pieces. In that case, it will keep only the biggest pieces if we have some little pieces around here. And now let's add a labs auto UVs. So we can add some UVs on the rocks. So this is the result for the first one. So now we can just see another one. And we can see that we have quite similar results. So to avoid this problem, we can add a different value for the offset of the noise here. So to add a random offset value for each individual pieces, we can use the metadata node. So here we can select the first node of the loop. And here you can click on create meta import node. So we can rename it something like iterations. Now you can select the volume noise fog, and here inside the offset we can type a little expressions. So we can get the data from the meta import node here. So let's type detail, and here we can type the name of the node, which is iterations. Here we want to have access to the iterations attributes, and we can type 0. So now we can create a random value based on that. So let's type round. So the round function will add a value between 0 and 1, so we can fit that to another value. So let's add the fit 01. In that case, it will fit the value from 0 to 1, and we can fit that to maybe 0 to 10. In that case, we have an offset value from 0 to 10 applied randomly to the different chunks. So now to see the results of the rocks, you can just disable the single pass at the end of the loop. And now we can delete some attributes. So let's add an attribute delete. And here we can keep only the UVs. So you can go to the vertex attribute and you can keep UVs and click on delete non-selected. So now we can add a null. And let's specify this is the output for the rocks. So we can type all pieces. So now we want to split them to export them as a Redshift proxy. So to do that, we can use a class attribute. So let's add a new connectivity node. In that case, we can create a new class attribute for each individual pieces. And now we can add a blast node. So here with the blast, we can type at class equal 0. We can choose points because class is a point attribute, and you can click on delete non-selected. So in that case, it will keep the rocks with the class attribute at 0 and delete everything else. So now you can add a material subnode, and you can add a Redshift proxy output. So now we want to create some materials. So we can go back to the object levels. Here you can add a material network. You can rename it like RS mat. You can dive inside, and here you can add the RS material builder. So here you can rename it something like rock 01. You can copy that 5 times because we have 5 different rocks and we want to assign 5 different materials. But if you want, you can assign the same material for each rocks. It's up to you. But in my case, I will add 5 materials. So now I can go back to the object level. I can go back to the Geo1, and here under the material subnode, I can select my materials. So for the first one, I can select my rock 1.
Ready to level up your Houdini pipeline? Get the Houdini script pack. Complete toolkit, 7 powerful tools today, plus every future release with free updates. Save time on composition, geometry splitting, material creation, and more. YouTube subscribers get 50% off with code TOOLKIT. Click the link in the description and transform your workflow today.
So now I can select my Redshift proxy output. And here I can go to Archive tab, and I can change the file name to $heap, and I can create a folder called proxy. And here I can create a name for each proxy. So in my case, I will put maybe something like rock with $OS, which is the name of the node. And I think we can put that for the name of the proxy. So this is for the first pieces. So we can copy that and paste it here. So now we can replace that with a class number 1. We can change the material to rock number 2. We can copy that one more time. This time for the class number 2, we can change the name of the material to rock 3. We can do the same for the class number 3. And we can change the material name to rock number 4. And the last one is for the class number 4. And we can change the material name to rock number 5. So if you want to automate this process to export your Redshift proxy in one single click and create the blast node, material node, assign material, and export all Redshift proxy in one single click, you can use a tool called Redshift Proxy Exporter, and this tool is included in the pack with all free updates. You can also check the link in the description if you want to get only this tool. So here let's take the connectivity node. Let's add a null after this one. And here we can get the null here with the class attribute made by the connectivity node. And here you can select the attribute you want to use to split your geometry. So in my case, I will use the class attribute. So here you can assign a materials. So in my case, I will not assign any material here for the material subnode because I will assign them manually because I want to assign different material for each individual Redshift proxy. So here you can define a name for the proxy, and here you can define a digit on the start index. So in my case, I will start at 0. And here you can define a path to save your Redshift proxy. So in my case, maybe I can create a test folder. and Redshift folder, and I think we are good. So I will render only one frame for each individual pieces because this is not an animations. And here you can create proxy, and you can see it will create everything. So the blast node, the material sub node, and the Redshift proxy output. And here you can see on the Redshift proxy output under the archive tab, it will replace the file name with the file we have defined here on the UI. And it will take the name of the node to create different export for multiple Redshift proxy. So let's click on render to disk and let's see how it will export every tool. So click on render to disk. And now you can see it will export everything. So you can click on OK, and here you can open your project folder, and you can see that it will create a test folder. And here we have the Redshift folder because we have defined a folder for Redshift. And here you can see that we have our proxy here. So now we can export our proxy under the $heap. So you can just click on render to disk. So here you can see it will create a folder called proxy, and it puts the first rock inside this folder. So let's do the same for the second one. We can click on render to disk. Same for the third one. Same for the next one, and same for the last one. And now you can see the results for the folder. We can see that we have the rock number 1, 2, 3, 4, and 5. So we have 5 rocks under the proxy folder. So now to assign this rock to the point of the particle simulation, we can go back to the object level here. So we can disable this one. Maybe we can copy the out particle null here. So Control C. You can go back to the object level. Let's create a new geometry node, and you can rename it something like render particles. We can dive inside, and here you can add an object merge. You can paste the null here. So in that case, you can import the particle simulation here to this object. So we can go to the frame 48. And here we can go back to the object level and to the materials. So to see the result of the material of each different rocks, we can change the color of each materials. So for the first one, I will put the color to red. For the second one, I will put the color to blue. For the third one, I will put the color to green. For the next one, I will put the color to yellow. And for the last one, I will put the color to orange. So now we have our point here from the particle simulations. We can create a p-scale attribute for the points. So to do that, let's add an attribute adjust float. And here we can just put the attribute name, which is by default p-scale, which is what we want. And here we can put that to random. And here we can put the minimum value to 0.2 and the maximum to 0.1. And here you can define the ramp. So maybe we can select these two. You can just click on these little icons and put that to constant. And now we can create a ramp, something like this. So maybe we can create this kind of ramp. In that case, we have only small amounts of particles with the maximum p-scale at 1, and most of them with a particle between 0.2 and 0.4. So I think it's good. Now we can add the attribute randomize. And here we can randomize the orient attribute. So we can put orient. And here we can put the dimension to 4. So now let's add an attribute wrangles, and here we can just multiply the p-scale in case we want to increase or decrease the global scale value for each point. So to do that, we can type f at p-scale times equal, and we can create a channel float, and we can name it something like scale mult. So here we can create this channel by clicking on this little icon, and you can put the value at 0.1. In that case, we can decrease the global scale of each point. Otherwise, I think the pieces will be very huge. So now let's add a point wrangle. And here with the point wrangle, we can assign the proxies that we have exported before to the points, and we can assign them randomly based on the ID attribute. So to do that, we can create a first integer variable called total, which is the total number of the proxy. In our case, we have 5 proxy geometry. So we can create a channel integer, and we can rename it something like total proxies. So now we can create an index variables, and we can type int. We can use the fit01 functions. We can use the round functions. And here we can type at ID. And here we can map that from 0 to total variables minus 1. So now to apply the proxy on the points, we can use the attribute called s for string at instance file. And here we can use the path of the proxy with the printf functions. So let's use printf. And here in my case, the proxy are located under my $heap, under my proxy folder. So here I have to type the name of the output for the proxy. So I can Control V. So this is the name I have in my folder. So you can see that I have rock, Redshift proxy output 1, output 2, output 3, 4, 5, and so on. So here I can just replace the output value here. So here instead of 1 at the end, after the output 1, I can replace the 1 by $D. And here I can put .rs because this is the extension used for the Redshift proxy. And here I can use the index value plus 1. And now you can add a null. And here you can rename it render particles. So if you want to visualize the points, maybe you can use a delete node. And here for the delete, you can go to points, you can go to random, and you can delete maybe something like 90% of the points. You can add a null, and we can rename this one for viz. So this one is for viz, and this one is for render. So to render this one and visualize this one, you can display this one in blue, and you can put that in purple by pressing Ctrl and click. So in that case, it will render this node while you are just display this one. So here you can go back to the object. You can add a camera. So let's add a camera node. And here you can go to view. You can put that to maybe this one. And here you can select your camera. You can press the lock icon here. And you can go to maybe something like this. You can add a light. So let's add RS DOM. And here you can go to light. You can select an HGY map here. So now we can enable the render view. So click on Windows, new floating panel. And here you can click on the plus icons and you can open the Redshift render view. And here you can just click on play. So this is what I have at the moment, and we don't have any color on the pieces because I've exported all my Redshift proxy before applying the different color on the materials. So to avoid this problem, you can select your geometry container here. You can go to the Redshift object option. So if you don't have this tab, you can go to Redshift and you can click on add object parameters. And here you can go to the instancing tab and you can click on override instance proxy material from scene materials. So in that case, you can update your material here and it will update them to the proxy files. So now let's click on play and let's see the result. Of course, don't forget to go back to your render particle node here, go to the point wrangle and don't forget to enable this little channel that we have created. So click on that and put the total proxy. So in my case, I have 5 pieces, so I will put 5 here. And now we can just open the render view and make a new render. So now you can see that we have some rocks scattered on different points and we have multiple colors. So that means the Redshift proxy are applied randomly on the different points. And now if you want, you can just, of course, change your materials. So for now, this is just random color to see the results if the rocks is correctly applied randomly on the points. But now you can create your own material if you want. So that's pretty much it. So now we have way more interesting results for your particle render. So it's definitely way better to render this kind of object on your particles than using the default spheres. So if you want to go close up, maybe something like here and see the results. Now you can see it's way more organic to render this kind of object than using the simple spheres by default. And you can see it's very, very fast to render. So you can use complex objects and render them like a million particles like this with this method. So that's it for today, guys. I hope you enjoyed it. Don't forget that you can get the project file with the link in the descriptions. You can also get access to the different tools with the link in the descriptions if you want to simplify your workflow with Houdini. So I see you in the next one. Bye-bye. That's it for today, guys. Thanks for watching and don't forget to subscribe to our channel and check artivoxer.com to get premium 3D resources. You can access to this project file with our Artifiles membership. See you in the next one. Bye.